that came up, superfood treatment. And what I want to use this as an example of is the amount of information that is present online, in magazines, and so on. And all of us have a very sincere wish to inform ourselves, educate ourselves, if there's something we can do, if there's something we can do to prevent cognitive decline, etc. We want to know about that. But there are unfortunately a lot of charlatans who take advantage of people's very sincere attempt to try to find information. And so regrettably, there's a lot of information available that is very dubious. So I want to use one example and just point out a few things about this particular example that maybe you can think about when you do research or when you encounter an article or you come across something that maybe a friend tells you or something you've read somewhere. Okay, so when I Googled brain health, this website came up and they had a couple of pages dedicated to blueberries and the brain. So they start off by talking about blueberries being one of nature's nutritional wonders, thought by some experts to benefit brain function. Blueberries are loaded with anthocyanins, a powerful phytochemical and antioxidant. Anthocyanins are a member of the flavonoid family. They give the blueberry its deep purple color. Studies conducted by Ronald Pryor, PhD, at the Jean Mayer USDA Human Nutrition Center on Aging at Tufts University ranked blueberries #1 in antioxidant activity when compared with 40 other commercially available fruits and vegetables. 1/2 cup of blueberries delivers as much antioxidant power as 5 servings of other fruits and vegetables such as peas, carrots, apples, squash, and broccoli. Research done on aging rats has produced intriguing results. When fed the human equivalent of 1 cup of blueberries per day, the rats showed improvements in both balance and coordination. These improvements are due to better cell communication in the brains of these rats. Because blueberries are rich in phytonutrients, especially polyphenols and flavonoids, these findings should come as no surprise. Phytonutrients improve communication among cells. By helping our brain cells communicate more efficiently, blueberries are actually helping us to halt the progression of degenerative diseases associated with the aging brain. This is because the primary reason that humans develop age-related degenerative brain diseases, such as dementia and Alzheimer's disease, is because our brain cells become less effective at communicating with each other as we age. Signals that cells send out to neighboring cells weakens over time. When these signals become too weak, neurological pathways are lost and brain functions are diminished. So many readers would think that this sounds plausible. There seems to potentially be some scientific background to this. It's couched with some technical terms, and so many people would buy into this idea. So I went to have a look a little further on their website, and one of the things that comes up is a section on all of their books that they sell, which apparently have sold millions of copies all over the world. They have a very extensive section where you can buy things, particularly the superfoods. And most interesting, this organization, one of the co-founders is a man by the name of Dr. Steven Pratt. And he says here that he is a world-renowned authority on the role of nutrition and lifestyle in the prevention of disease and optimizing health. So I went to have a look on PubMed, which is the major database for all medical or health-related research, to see what research Dr. Pratt has done to qualify for this title of world-renowned authority on the role of nutrition and lifestyle. So perhaps Dr. Pratt has done very meaningful research, but the only 2 publications I could find on PubMed are 2 publications from 1987 and 1984. He's actually an ophthalmologist by specialization, and both those publications relate to one is actually just an opinion piece on ophthalmology surgery, and one is a review of ophthalmology cases. So then I thought, okay, well, maybe his data is available somewhere else. So I continued to look for him on Google, and I got to about page 6 of my Google search, and all I found were sites about his books, sites that bring you back to this website, and sites that talk about where you can make an appointment with him, and all of them start with this world-renowned authority on the role of nutrition and lifestyle in the prevention of disease and optimizing health. So, as I said, perhaps my search was not extensive enough, but I do suspect that if someone is a world-renowned authority, I shouldn't have to search quite this hard to find the research that gives them the credibility to make a statement like that. So, as I said, I checked about his research. He also claims to be the person who coined the term superfoods. And superfoods earned in Germany between 2016 and 2017 3.2 billion euros. In the US, the growth in the market for superfoods between 2017 and 2022 is 155.8 billion US dollars. So I then looked further, did some research on superfoods in general, on PubMed, where peer-reviewed publications appear, and there is no conclusive evidence that superfoods offer the health benefits that they are suggested to offer. And I'll talk about blueberries as a particular example. And then, as I mentioned, one does have to question the credibility of the source, and there's a lot that's stated, but no evidence that's provided to back up these statements. So I want to go through this section line by line, and let's identify some of the red flags. So they say research done on aging rats has produced intriguing results. So the first thing I really, really want to stress is that humans and animals are not the same. I think we all conceptually can understand that, but a lot of research that is put out into the public domain talks about research done on animals. Animals that didn't eat meat lived longer than animals that did. Animals that were exposed to X had a better outcome than animals that were exposed to Y. And while that is all useful information, that doesn't mean that it applies to human beings. Similarly, they will say that they've done research on neurons, and if they've exposed neurons to certain antioxidants, it changes their electrical activity. That's great. That's very useful information that we can take forward, but it doesn't mean that it applies to the neurons in your brain or my brain. Because neurons in a dish are not neurons that are the same as a brain. Those are neurons that have been taken from stem cells that have been exposed to growth hormones to send them down the development stream into neurons, so they are artificial in the sense of the way in which they've been created. They don't have the history that your neurons do, the degree of interaction that your neurons have with other neurons, the exposure to the general milieu, your experience, your history, etc. These are a good proxy, but these are not equivalent to the cells of the human brain or any other part of the body. So human research focuses on specific steps that are taken, and we start off with experimental research, and this is research in animals and research in cells. And it's very valuable because it generates hypotheses, it gives us ideas of things that could be useful. But then we need to validate those findings. So often they need to be validated not in only one animal model, but more than one animal model, because one animal is not the same as another one. The immune system of the rabbit is very different from the mouse, which is very different from the rat. So the way in which they will respond to certain things is different. So if there's something that has a characteristic that is going to generalize across animals and therefore to humans, it needs to be validated in more than one animal study. After that, and often they will first do studies in non-human primates because non-human primates are most similar to humans. But once it's been established that this appears to be a validated hypothesis, a potential substance that could offer value to humans, it needs to be tested in a phase 1 trial in humans. A phase 1 trial is in a small group of humans, and it's to test safety. Then, if it's safe, they will do a phase 2 trial, which is in a bigger group of participants, and it's to test efficacy. So if blueberries or flavonoids shows value in animals, in multiple animal models, it's safe in humans, is it actually effective? Should we even bother to continue to spend money on it or not? We need to prove that first. That's a phase 2 trial. If it's shown to be both safe and effective, it then goes on to a phase 3 trial. And these are the big trials with many, many hundreds or thousands of participants that will often involve randomization and will often involve a group of people who will receive the drug or chemical or intervention that's being researched and a group of people who won't. And then one will compare whether a particular outcome is actually different between those two groups. So this is the proper process of research for humans. So it's wonderful to hear about things that are working in animals or working in cell culture models, but it doesn't end there. All right. So they talk about this research about blueberries showing improved balance and coordination, improvements in cell communication. There's no reference where this research comes from. So this could be something somebody decided. There's no evidence to back it up. They haven't provided any references of where they got this knowledge from. Then they go on to say, by helping our brain cells communicate more efficiently, blueberries are actually helping to halt the progression of degenerative disease. Now, from what you've learned over the last 4 days, what do you think of this statement? Right? So there's one big mistake which a lot of people make, and that is to conflate something that's associated with something as being the cause of that thing. Right? So we've discussed Alzheimer's over the course of this lecture series. And we've talked about how evidence shows a collection of amyloid beta and tau that leads to neuronal damage and degeneration, that leads to deficits in neuronal function, that leads to poor communication and breakdown of neuronal connections. Right. So poor communication of neuronal cells is indeed associated with Alzheimer's, but it is not the cause of Alzheimer's. So if you were to go and treat poor communication, that doesn't mean that you're going to halt the progression of Alzheimer's or even reverse it, as they suggest. So this is a really important concept. And I always think of it when I was studying in my undergraduate degree, there was an example to demonstrate this to us where they said sunburn and melting ice cream are associated with each other, therefore burning in the sun results in the melting of ice cream. Of course it doesn't. There is another factor that is associated with both of them, and that is going to the beach. You go to the beach, you get sunburned. You go to the beach, you eat an ice cream, it's hot, it melts. But so being able to properly determine causation is very tricky. It's tricky even for researchers, but definitely when it comes to popular science, be very cautious of this because it happens a lot. Association does not equal causation. Then they go on to say this is because the primary reason that humans develop age-related degenerative brain diseases such as dementia and Alzheimer's is because our brain cells become less effective at communicating with each other. So they talk about it being the primary reason. So we've already established that it's not a cause. And secondly, if we think back to when we looked at the Alzheimer's research, we know that it's not even only tau and amyloid beta, it's other things like the health of the vasculature of the brain. So first of all, to say that it's a cause is incorrect. To say that it's the primary reason is also incorrect. So I went and had a look at what research does there actually exist on blueberries. And Prof. Figagi said, I think on Monday, that there's always a glimmer of truth, often where there's smoke and mirrors. So there is indeed research. Blueberries contain flavonoids that belong to a group of polyphenols, and there is evidence to suggest in humans that consuming polyphenols or fruits and vegetables that contain them can result in an improvement in some cognitive tests. Now, this was a meta-analysis that was done. It looked at all the studies in humans that considered flavonoids and polyphenols, of which there were many different kinds. 16 studies showed a positive effect, 12 did not. But that effect was extremely small. And an improvement was seen in only 27% of the cognitive tests that they did. So in many of these studies, there was no change in the cognitive performance of their participants. And in the studies that did show a change, it was only in a few of the cognitive tests, and that change was very small. It is unclear what is the association between the dose of these polyphenols, the duration of taking these substances, and therefore the effect on cognitive performance. It's unclear whether the concentrations that are required to improve cognitive performance are actually available in the kinds of fruits and vegetables that we would be able to buy on a day-to-day basis in the shops. And the mode of action of how these polyphenols work is still unclear. And there are many different suggestions of how they could work. They could decrease inflammation, they could improve blood flow to the brain, they may have an acute effect, like if they improve blood flow to the brain, that helps at this minute. But in an hour's time, that effect is lost. If they have more long-term effects, then maybe that would endure. But one would need to do long-term research to actually control for all those things. So my point here is to say that research is very valuable, but highly complex. And before you allow yourself to commit to a particular eating regime or taking a particular drug or whatever it may be, just step back, have a look at the source that it comes from, consider that there are biases because human beings are often very biased. So we need to be cautious of a small sample size. One patient is not enough. You need to have a decent number of patients. Be careful of doctors and investigators who have a vested financial interest. Be careful if there's an apparent lack of expertise. What I did yesterday in terms of looking up that particular doctor took all of 5 minutes. There's a lot of information available. We have access to it. You can check. Look also if there's an apparent absence of scientific peer review. Right? So when we publish papers, those papers go out to other experts in our field who look at what we've done and evaluate whether what we've done makes sense in the context of information that currently exists. They look at whether the method that we've used was actually a method that was sound, and they look at whether the conclusions we've drawn from our data are actually conclusions that can be made from the data that we present. Right? So that's the importance of peer review. Yes. So I haven't looked particularly at ginkgo biloba, but if I look at many of the others, there may be some small effect, but I would suggest rather actually going to really check the evidence of that. Yes, sir. Yes. So the placebo effect is very real. We all know that. It is a real phenomenon. So many people might justify it and say, well, it doesn't matter if people are eating blueberries every day, if because of the placebo effect, it improves their cognitive function. Now, I would say, yes, that's fine. But that's not fine for as long as somebody's making billions and billions of dollars on that. So this is where I think that we need to just be cautious about, and also when people buy into an idea very sincerely, I think personally that that's criminal, to be purposefully deceiving people for your own financial interest. All right, so always look for real evidence if you can see some. Remember that animals and humans and cells are not the same. Also be cautious, anecdotes are not facts. If someone tells you a story of how they hung out of the window and it changed the way that their hair grew, Maybe it worked for that one individual, but that is a sample size of one. It doesn't mean that it's a fact. You need to get 100 people to hang out of the window, for the same amount of time, the same time of day, to have the same history when it comes to hair growth, etc., before you can conclusively say that hanging out of the window changes the way your hair grows. Association does not equal causation. Just because you see and hear information doesn't mean it's true. So the superfood stuff is everywhere. It's in the supermarkets, it's on the internet, it's in the magazines. Doesn't mean that it's true. And there's a psychologically proven phenomenon called communal reinforcement, where we are more inclined to believe things that people around us say are true. So just be cautious of that. And then we also have a bias towards positive evidence. We like to hear stories about something that works. It's much more pleasing to hear that blueberries will halt neurodegeneration. It's not as pleasing to hear that that's not the case. And again, psychologically, people have a proven bias towards positive information. So just bear that in mind as well. And we will remember positive stories. So you'll remember the story that someone told you of hanging out of the window that had an effect, but you won't remember the stories of people who've told you that they did that, but it didn't have an effect. And often the people won't tell you about it because there's nothing to tell. It doesn't mean that their experience was not a valuable piece of the data. And then we always judge information by our prior beliefs. And this is why the scientific method exists. It's taking into cognizance the fact that when we do research, we have a prior idea of what we want to find, and that's why we have to undergo peer review. Because we have a particular process where we try to do research without bringing our biases in, but we always still can. And that's why it's best to get objective opinions from people who know your field as well. There's a fantastic book by Ben Goldacre called Bad Science. I recommend it. And I like this particular quote where he says, no matter what you do with statistics about risk or recovery, your numbers will always have an inherently low psychological availability, unlike miracle cures, scare stories, and distressed patients. We have a tendency for drama. So these things, dramatic things, are often what we remember more so than actual facts and hard evidence. Okay, so a lot of people ask about concussion, and so we thought that maybe we should just give a little bit more information about concussion today. So I wanted to start off by playing these videos. This is a video from one of the American NFL games. And you can see this response here is a primitive brainstem response. This is in a game of rugby. Again, there's that same primitive brainstem response. And this is in a game of soccer. So this player was completely lights out. He eventually did wake up on the field. And there he is, staggering along, insisting that he wants to play on. Okay. So, as we mentioned the other day, the interest in concussion has increased exponentially. If you look at the number of publications related to concussion since 1996, you can see that there's a staggering increase. And this is partly because it's become we've become more aware of the potential impact that concussion has on the brain. And that started with the story of this pathologist who Will Smith plays in the movie. I recommend the movie. It's certainly very entertaining. It's very dramatized and Hollywoodized, but essentially it's based on the true story of an NFL player who was in his 40s. By the time he committed suicide, he'd lost all his money. He'd been involved in a lot of aggressive, violent behavior. He'd behaved badly towards his family, so he'd been isolated from all his family and friends. So he had a lot of behavioral and psychological problems, and then he shot himself in his car. but not in the head. So when the pathologist did the investigation, sorry, Tony, what's the name of that pathologist again?
Sorry?
What's the name of the pathologist? Omalu.
Bennett Omalu.
So when he did the autopsy, he decided to look at the brain, and he sliced the brain and realized that there were a lot of characteristics of the brain that looked very similar to what is seen in neurodegenerative disease. So this is an example here of a slice through a normal brain. And this is a slice through a boxer's brain, and boxers were known to have a condition which is associated with neurodegeneration. And what you can see, this dark rim here, is the collections of tau protein that have been laid down in the cortical layers. And this is the brain of an NFL player, and you can see that there is a lot that looks quite similar between them. They also have very clear evidence of tau protein deposition. So this stirred up a lot of discussion around the subject. This book was written to attempt to reveal the NFL's attempts at trying to suppress any data that suggested that concussion was associated with poor outcomes, that there were medical practitioners, doctors, neuropsychologists, neurologists who were working for the NFL who were producing evidence or data that wasn't providing the full picture, or they were trying to suppress evidence that did suggest that there was neurodegenerative disease in the NFL players. And so this became a massive, massive area of interest and panic in the public mind as well as in the academic arena. This is a player called Fernandez, who was a very successful NFL player, played in the big leagues for about 3 or 4 years, and he was incredibly successful. But increasingly over that time, he was said to have engaged in a lot of aggressive activities. So if they look back at his criminal record, and there were some instances where he was accused of assaulting people, instances where he was accused of being part of an assault that led to the death of one of the individuals involved. And finally, he actually was found guilty of killing the brother of his fiancée. And he was sentenced to jail. Soon after being sentenced, he committed suicide in his cell. And so when they did the post-mortem, they looked at his brain, and they found very clear signs, again, of tau deposition and neurodegenerative disease. And he was 27 years old at the time. So this obviously made headline news. And so with all these stories coming out, they decided to, because these again, of course, are anecdotes or single cases, they decided to launch an official study where they set up a biobank of brains, and they had people volunteer to donate their brains. And of those brains, 111 were donated by NFL players. And of the 111 brains donated, 110 of them were found to have signs of neurodegeneration and a disease which is referred to as chronic traumatic encephalopathy. Oh, sorry, the National Football League. Yes. And in the US, the National Football League and football in general, it's like a religion. People are incredibly devoted to their players, to the game, and so bringing up something of this nature was very controversial and still is very controversial. So I started off by pointing out the things to be aware of. And while this study certainly does provide some very damning evidence, there are limitations to this study that was done on the 111 brains. The one is that it's a selected autopsy series. So these are people who donated their brains. They may well have had reason to donate their brains because they felt that they were experiencing psychological or psychiatric difficulties, whereas there may be many, many other players who didn't feel that way and therefore didn't feel motivated to donate their brains. So it is a biased sample. We don't have any good epidemiological studies, so those are studies that can actually follow a patient or many patients, many players over time, and take account of the many things that happen during the course of their life, and then finally what the brain looks like at the end. And as I said, association doesn't mean causation. So it's possible that this deposition of tau and these signs of neurodegeneration may be due to other things that are also associated with being a professional sportsman. For example, taking steroids, performance-enhancing drugs, engaging in risk-taking behavior. There are other things that could potentially contribute to this kind of condition, apart just from the concussion. So that's something that we mustn't lose sight of. Also, there are a number of other changes to the brain that may be associated with other forms of aging of the brain. And therefore, it's not purely just a case of neurodegeneration of one particular type, but there are other things that happen to the brains as well that could be as a result of other things. There's also the question of genetic vulnerability. So it's not conclusive yet, but it's very possible that certain people are genetically more vulnerable to the long-term negative repercussions of repeated concussions than other people are. And again, until we get a completely unbiased selection, if one were to say, you know, the next 200 NFL players are all required to donate their brains, we don't have a completely unbiased sample in which to draw final conclusions about causation. Somebody was asking about how it manifests, so deficits in memory and executive function, and then behavioral and personality changes. Many of these players have reported bad behavior and difficulties with social interaction. So just a few stats about concussion in general. So it does occur quite frequently. Traumatic brain injury is a very big area. You will recall I showed you that it can be mild and moderate, and it can be severe. So a lot of research has focused on severe injury up until recently, and getting a proper sense of how common mild and moderate injuries are also depends on people reporting and actually presenting to a hospital or clinic, etc. And many of them might not do that because it's minor. It happens often in football, both at a professional level and at a school level, and of course, it's very common in soldiers who are at war, who are obviously exposed to blast injuries. Risk factors include previous concussions. There is evidence to suggest that maybe women or young women are more susceptible than men, but there could be reasons for that. So it's been found to be that more female soccer players report concussive events than male soccer players, but that's often from heading the ball, and it may be that male players have stronger neck muscles, and that may be what makes the females a little bit more vulnerable. Of course, being young, so we're obviously particularly concerned about children who are playing contact sports, those who take a long time to recover, and obviously the more severe the injury is, and if there are any other pre-morbid factors, so any other diseases or things that are associated with it. What happens? Many things. We won't go into all of them. One also needs to consider the biomechanics. One form of concussion is not the same as another form of concussion. You saw in those videos, falling on your head is different maybe from someone kicking you in the head. And so what that means in terms of the impact on the brain and the nature of the injury is still something that's being investigated. For your interest, symptoms of concussion can be headaches, dizziness. Many people will describe that they feel like they're in a fog, emotional fatigue, changes in behavior, impairment in cognition, disturbances with sleep, and sometimes those symptoms may take a while before they manifest, and they definitely need time to resolve.
Yes. Do we have evidence of concussion in South African rugby players, for instance? I mean, rugby playing surely is bad news.
So I don't know of evidence, formal studies that have been done in South African rugby players, Tony.
There are some, but nothing to the scale of NFL, and the results are a little bit contradictory. For lots of different reasons, the way that head injuries occur not only in NFL, the National Football League, as well as in ice hockey, because that's, people often joke about ice hockey. They went to a fight match and a hockey game broke out because it's just so common. The way that rugby players tackle, in many ways, it's that they train to avoid the head, whereas in NFL the head is often the target, and because they're using a helmet, they use the head as a weapon. Of course, concussions do happen in rugby, but the exact frequency is still debated. The exact consequences are debated, and probably is a reflection of a huge amount of heterogeneity. So uncontrolled rugby playing at school level and at varsity level and professional level are very, very different based on the supervision. So there's probably a lot of heterogeneity.
And I think also one of the things that makes those sorts of studies very difficult is that the diagnosis of concussion is so difficult. So I think that's on the next slide. So there are a lot of neuropsychological tests that are done. There's no clear battery of tests that are recommended, a standard battery that everybody does. But a lot of those tests will be based on performance at the beginning of the season and performance at the end of the season. And so players don't want to be taken off the field, obviously. So some of them will purposefully perform poorly on the preseason test so that if they do have decreased performance by the time of the postseason test, it's not that obvious. So that's, and self-report, because there's no clear imaging feature of concussion. You can't say, oh, well, can I take my child to the emergency room and they'll do a scan of the brain and they'll be able to tell us if they have had a concussion or not. There is no clear imaging feature of it. There's a lot of research to try to look for a biomarker in the blood, so perhaps you'll be familiar with once a heart attack has occurred, you can actually do a blood test to pick up that a heart attack has occurred and how severe it is. So they're trying to find something similar for the brain, but we're not quite there yet. There have been a lot of tests that have been tried. Some of them have potential, but they're not sensitive or specific enough. So a lot of the diagnosis also revolves around self-report. So you ask a player how they're feeling, and they may say, I feel fine. And if they're not staggering around, obviously, you may believe that, so it becomes difficult to make the diagnosis, and therefore when one does studies in at a professional level or even at a school level, it can be complicated. Yes.
May I add to that for the medical terms? There's a medical concussion and a medical contusion.
Yeah.
The difference is very difficult to prove, but you're talking mainly on medical contusion, which implies damage to the brain, whereas in a medical concussion, it's presumed that whatever damage to the brain is temporary and not
Yes. So if it was a contusion, then you'd see it on the scan. And that wouldn't be the case in the more mild and moderate forms of head injury. That's why it becomes more complicated. Yes, ma'am. Yes. So there is no clear rule on that, but I think I have that on the next slide. So the general recommendation is rest until the symptoms have ceased, not returning to play until the symptoms have ceased, that if one has repeated concussions, that probably it's not advisable to return to play at all after another one. But the important thing is to have somebody who's a medical professional who's experienced in understanding concussion and evaluating players, who would be able to look at both the objective and the subjective information and be able to guide decisions around how long they need to recover, when they can return to play, and so on. Did you have anything you wanted to add to that? No?
Is it true that concussion can lead to motor neuron disease?
So I haven't seen any evidence about that. I mean, the evidence about the long-term effects of concussion have largely revolved around the neurodegeneration, the collection of tau, amyloid beta, that sort of thing that we've seen. Motor neuron disease, as far as I understand, is quite a different disease, and it has different factors that would be relevant from the factors relevant to concussion and head injuries.
There's been lots of suggestion about that, because, as you know, there have been a few famous players who have developed motor neuron disease, but there's no correlation. They've looked at all sorts of things, including the chemicals that are used for the lines on the field, and try to find some association, but no, and it's probably random. Rugby players, sports players get motor neuron disease. People who've never played sport get motor neuron disease.
May I add to that one? You're telling me it's not important for one particular case, and I agree with you as well. But I got a concussion in 19...
Do you want to maybe use the mic so everyone can hear?
Why I'm commenting complete rest of 1 to 3 days. In the days when I had the concussion, which is about 1958 or something like that, no, earlier, I was confined to bed for 6 weeks. So, sorry. I'm commenting on the complete rest for 1 to 3 days, then graduated return. And I'm just telling a personal case. I had a concussion in about 1958 or somewhere around that time, earlier, 1954. And I was diagnosed as a contusion, 1 grade worse than a concussion, confined to bed for 6 weeks. That was the therapy in those days. And I don't know whether the 1 to 3 days was...
So, did everybody hear the question? Okay, so it's essentially a question of recovery time. The recovery time depends on the event. There isn't a one-size-fits-all. If one has a contusion, you've definitely had a more severe injury than someone who has no signs of a contusion. So the rule of thumb is recovery until symptoms subside. In the past, they used to suggest that people rested in a dark room, but that has now, there's been evidence to suggest that that doesn't help to be in a dark room, but one wants to have rest from activity that involves sport and physical activity, but you don't necessarily want to completely rest any sensory input, intellectual input, etc. Yes. So these are just drugs that have been used as part of symptom control, but there isn't any. I shouldn't actually have included that. Let me take it away. There are no set drugs that are recommended. Regular taking amitriptyline? I don't know.
Yeah, because it changes neurotransmitters. That's why it's used for in psychiatry quite widely. Those are by no means drugs that should be used. Those are drugs that have been used, and it's in patients with concussion. But it's a reflection of a huge amount of heterogeneity, not only in the severity of symptoms, but also the makeup of symptoms as well. And so it's just what it is a reflection of it's a whole bag of very, very different patients with very, very different groups of symptoms, all of which may need targeted therapy, not because they've got concussion, but because they've got specific symptoms.
So in other words, taking amitriptyline
No. It can be used for migraine as well, yeah. Just because it's used in psychiatry doesn't mean if you're on amitriptyline, you've got a psychiatric disorder. It's a symptomatic treatment.
That's rather ask Prof directly. Yes. Oh. Well, I suppose with flights, pressure is a concern, but I mean, would you tell someone not to fly?
I think it just depends on how symptomatic they are. They're pressure control planes, of course, but as you know, when your ears pop, it's not completely pressure controlled, and certainly may lead to an exacerbation of symptoms. So, in terms of what my recommendation would be, it would depend on A, how bad the symptoms are, and B, how desperately they need to fly. So you just have to be sensible and be individualistic about it. The chances of them doing any major damage, particularly if they've got a normal scan, I certainly wouldn't let them fly if they're symptomatic and they haven't had a scan. But if they've had a scan and they still have symptoms and they desperately want to fly, they're probably not going to do any damage, but their symptoms may get worse. So it's always like everything in life, it's a balance of benefits and risks.
Yes, ma'am. No. Yeah. No, it's not possible, because you can imagine if you were to surgically go in and scrape out neurons that are very, very small to begin with, you'd probably cause a lot of damage, so it wouldn't be a sensible thing to do. No. I just want to emphasize that when it comes to concussion, there are no set gold standards for recovery, treatment, diagnosis, testing, definition, etc. It's a very grey area still. It's very woolly still. And so it's very topical at the moment, and we just wanted to spend a little bit more time on it so that we could address some more of the questions and give a little bit more of the background. But it's generated a lot of panic. That's not what we necessarily wanting to do. We don't all need to panic about it. It's just about being aware. And making sensible decisions. So if someone's had a concussion, don't put them back on the field, and let them rest. If they've had repeated concussions, probably better, to consider not playing for a while. So it's just about being sensible, because there are potentially long-term consequences that one really would prefer to avoid. Yes, ma'am. So, at the moment, okay, so the question was if a brain that has experienced a concussion could go on to have a prolonged inflammatory response, could a treatment be developed that could maybe target that? So, I would say that at the moment we're dealing with hypotheses about what exactly is going on. It's not clear exactly the processes that are being set up. For the reasons that we discussed yesterday, the brain is hidden from our view. So it's very difficult to actually know exactly what's occurring, both acutely after the concussion and also in the long term, in terms of if there are chronic things that are going on. And I think that Prof would agree, you wouldn't want to venture to treat someone, especially long term, if you're not sure what you're treating, and you also have the risk of the negative side effects of treatment over the long term, and you would definitely want to avoid those if they don't have any benefit to begin with. So one would first need to know what's going on, how best to treat it, does that treatment actually benefit the patient in the long term, and is it safe? So I think that is a good question, but we're quite far away from getting to that point. Would you agree? Yeah.
So your long-term effects slide.
Yes.
Are those proven long-term effects or claims?
So those are long-term effects that have been reported. Yes. Yes.
Some neurologists have prescribed anti-epileptic
long-term use of that medicine, would that be damaging to the brain and create other problems in the future, especially if the entity is quite young?
So I think Prof gave an answer that I think applies here as well, where it depends what causes the headaches. I think to some degree, it depends on what is the risk and benefit ratio of giving those drugs as opposed to not giving those drugs, and what are the other sort of circumstances around that particular case, and it may vary from sort of case to case. Would you add to that? No, she said headaches. Yeah. Okay. Yes, so we didn't actually decide to talk about that today because a lot of it actually Prof covered on Wednesday's lecture. And so many people have come up to us with such great questions that we wanted to answer those in depth. But what the concept was behind that lecture was to look at key individuals in the past who have either incurred pathology to their own brains or been the victim of somebody else's brain pathology, and that may have changed the course of history. So there's certain presidents, American presidents, that have been assassinated by people who have had brain conditions. King Henry of France incurred a traumatic brain injury when he was jousting, eventually led to his death. And so Queen Catherine took over his reign, and that changed the course of history subsequent to that. So that was the feel of the talk that we were going for. But we thought maybe we told enough stories on Wednesday, and we'd rather give people the chance to address some of the questions. Somebody did ask about epigenetics. I can talk about that, or we can just continue to take questions from the room. Shall I talk about epigenetics? Okay. Okay, so I didn't address this when we were talking about DNA and genes the other day. That's because I gave obviously a simplified version of the genetics that we think about in reference to the brain. It's obviously a lot more complex than what I described. But just to give you a very basic idea of what epigenetics is, if you remember, I gave the analogy that the DNA is like the language of the story, which is the gene. So the epigenetic factors, I would say, is almost like the editor. Doesn't change the genetic material, so it doesn't change the language, but it changes the expression of the genes. So what are some examples of that? So some things like, for example, they found that during one of the great famines of the past, can't remember which year it was in, the children born those mothers had difficulties metabolizing they had the higher risk of cardiovascular disease, they had difficulties metabolizing meat and so on. And the idea is that environmental stimuli can potentially not change your genetic material, but just alter the way in which it's being expressed. And that some of those changes can then be inherited. So if you look at, for example, how animals have evolved over time. So giraffes, for example, their necks have grown longer and longer over time. That doesn't necessarily mean that their genetic code has changed, but rather that the genes that would code for the length of the neck have been expressed differently, and that trait has been inherited by their progeny, and so that trait continues. So there's some epigenetic traits that appear to be inherited, and there's some epigenetic traits that appear only to be present in the course of an individual's life. And some of those can also be related to something that's not heritable, like damage to the DNA. So if the DNA undergoes damage, which can be as a result of exposure to pollution, chemicals, whatever, the consequence of the damage to the DNA can change the expression of DNA, and that is an epigenetic phenomenon. So these are some ideas of different things that can influence DNA expression. So one of the things that's interesting is they've done studies in twins, so identical twins, and they look at their epigenetic characteristics when they are young, and they look at them when they are older, and they are different. And they've inherited exactly the same genetic material, so those differences are largely a function of things that they've encountered or experienced. Those are essentially what